Welcome back to my YouTube channel. I'm Pamela Talavera. And for today's video, I'm going to discuss to you what is the OSI model. So, let's start. The OSI model, or the Open System Interconnection Model, is a conceptual framework used to describe the functions of a networking system. The OSI model characterizes computing functions into a universal set of rules and requirements in order to support interoperability between different products and software. In the OSI reference model, the communication between the computing system are split into 7 different abstraction layers. So, the first layers of the OSI model is the physical layer. It is the lowest layer of the OSI model. Is concerned with electrically or optically transmitting raw unstructured data bits across the network from the physical layer of the sending device to the physical layer of the receiving device. It can conclude specifications such as voltage, pin layout, cabling, and radio frequencies. So the second one is the data link layer. At the data link layer, directly connected nodes are used to perform node-to-node data transfer where data is packaged into frames. The data link layer are also corrects errors that may have occurred at the physical layer. So the third one is the network layer. The network layer is responsible for receiving frameworks from the data link layer and delivering them to their intended destinations based on the addresses contained inside the frame. The network layer finds the destination by using logical addresses such as IP or Internet Protocol. And at this layer, routers are crucial component used to quite literally route information where it needs to go between networks. The fourth one is the transport layer. It is a layer that manages the delivery and error checking of data packets. It regulates the size, sequencing, and ultimately the transfer of a data between systems and hosts. One of the most common examples of the transport layer is the TCP, or the Transmission Control Protocol. The fifth one is the session layer. It controls the conversations between different computers. A session or a connection between machines is set up, managed, and terminated at layer 5. The session layer services also include authentication and reconnections. The sixth one is the presentation layer. The presentation layer formats or translates data for the application layer based on the syntax or semantics that the application accepts. Because of this, it also called the syntax layer. This layer can also handle the encryption and decryptions required by the application layer. So the last layer is the application layer, and this layer, both the end user and the application layer interact directly with the software application. This layer sees network services provided to end user such as a web browser or Office 365. The application layer identifies communication partners, resource, availability, and synchronized communication. So, let's proceed to the next. It is the TCP or IP model. It is the prerequisite of the layers of the OSI model. So, the OSI model, we just look at it just a reference logical model. It was designed to describe the functions of the communication system by dividing the communication procedure into smaller and simpler components. But when we talk about the TCP model, it was designed and developed by Department of the Defense or the DoD in 1960s and is based on the standard protocols. It stands for the Transmission Control Protocol or the Internet Protocol. The TCP/IP model is a concise version of the OSI model. So, it contains 4 layers unlike 7 layers in the OSI model. The layers are the process application layer, and the process application layer. At this layer performs the function of the top 3 layers of the OSI model. The application, presentation, and session layer. It is responsible for node-to-node communication and control user interface specification. So the second one is the host-to-host layer or at this layer is analogous to the transport layer of the OSI model. It is responsible for end-to-end end-to-end communication and error-free delivery of data. It shields the upper layer application from the complexity of a data. It has two main protocols present at this layer. It is the TCP or it is known as the Transmission Control Protocol, and it is known to provide reliable and error-free communication between end systems. So the second one is the UDP or the User Datagram Protocol. At this data protocol, it does not provide any such features, but it is the go-to-go protocol if your application does not require reliable transport as it is very cost-effective. So the next one is the internet layer. At this layer parallels the functions of the OSI model layer. It defines the protocol which are responsible for logical transmission of a data. And the main protocols residing at this layer are the IP or the Internet Protocol, and it is responsible for delivering packets from the source host to the destination host by looking at the IP addresses. So, this IP has two versions. It is the IPv4 and the IPv6. So, the IPv4 is the one that most of us using this at the websites. But the IPv6 is growing as much as the number of the IPv4 addresses are limited in the number when compared to the number of users. So, the last is the network access or the link layer. So the network access layer corresponds to the combination of data link layer and physical layer of the OSI model. It looks out for the hardware addressing, and the protocols present in this layer allows for the physical transmission. So let's proceed to the encapsulation and decapsulation. So the encapsulation is a process of adding information to the application layer data as it is sent through each model layer. Each time the data passes a layer, a new protocol data unit or the PDU is created. The data sent from the application layer The data sent from the application layer has added a header with information on the TCP or UDP in the transport layer. Now the data is known as the segment, and the network models are used to standardize network communication when sending data from the location to the other. The data goes through a number of the layers. The TCP/IP model has 4 layers. They are application layer, transport layer, internet layer, and network access layer. Each layer performs a specific role in the TCP/IP model. So let's proceed to the decapsulation. Decapsulation, as I explained in the encapsulation process, the frame goes out of the host computer to the network. Then it reaches the destination host. In the destination host, the frame is decapsulated in the reverse order till the application layer. So when it is sent to the network layer, it is a packet and has data TCP or UDP header and header with the IP addresses. Then the packet reaches the transport layer. Now it is a segment and contains data and TCP UDP header. Finally, the segment reaches the application layer in the application layer. So in summary, a network is a connection with a data large of a devices. These devices are different from one to one another that can create compatibility issues. To avoid that, all devices in the network use the standard network model for data communication. One of our major network model is the TCP or IP model. At this model, it is consists of numbers of layers. So the data that which be transmitted to a new location should go through each layer because of this model consisting. And when the data reaches the destination in each layer, the added information is unpacked. So the difference between encapsulation and decapsulation is that in encapsulation, the data is moving from upper layer to the lower layer, and each layer includes a bundle of information called a header along with the actual data, while in decapsulation, the data is moving from lower layer to upper layer, and each layer unpacks the corresponding layers to obtain the actual data. So let's proceed to the ARP process. The ARP process, or the address resolution itself, is a two-step process. It is a request and a response. So it is start with the initiator sending an ARP request as a broadcast frame to that entire network. Since it was a broadcast, all nodes on the network will receive the ARP request. Sorry guys. It will take a look at the content of the ARP request to determine whether they are intended target. The node which is target of a ARP request will send An ERP responds back to the original sender. Since the target knows who sent the initial ARP request, it is able to respond unicast directly back to the initiator. I'm sorry guys, so that's all. See you on my next vlog. Thank you.